So this problem says, what is the mass of 7.8 times 10 to the 7th molecules of ibuprofen? So they're asking, they want to know the mass, which would be grams. That's the units for mass. And then they've given us molecules. So in previous problems, we have worked with both of these, but this is actually two separate problems in one. So what I know is that grams are connected to moles from using the molar mass, which is calculated from the formula and the periodic table. But they don't want, we're not given, moles, we're given molecules. And so I also know that moles are connected to molecules with Avogadro's number, which is the relationship 1 mole is 6.02 times 10 to the 23rd molecules. All right, so when I look at this problem, what I'm given is molecules. So I'm all the way over here. But I need grams, which is all the way on the left-hand side. So I'm going to have to do two problems. First, I'm going to have to take molecules and make them turn into moles. And then second, I'm going to have to take those moles and turn them into grams with the molar mass. So let's start with the first part. So I'm going to write down the molecules that I'm given. So this is given. And molecules are going to convert into moles by dividing by the 6.02 times 10 to the 23rd molecules. And how I know I'm dividing is because if you're given molecules, the molecules has to be on the bottom, so you get moles. And recall from previous videos, for some of you, when you divide in the calculator, you'll need to put anything in scientific notation when you're dividing by it in parentheses. So that will be the first part. We're going from molecules to moles. So 7.8 times 10 to the 17th divided by 6.02 times 10 to the 23rd. Oops. And I get a really small number. I'm going to write it down here, not rounding, but I'm going to keep it in my computer, my calculator, because I'm going to use it again. So it has 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5 zeros. Then a 1, 2, 9, 6. And that's the number of moles that it is. So now I'm going to do the second part of this problem. And I'm going to go from the moles I just calculated to grams, but I need the molar mass. So I guess I'm going to have to write this number down because I need my calculator again. 1, 2, oops. I'm just recording the number that's up there. 1, 2, 9, 6 moles. Okay, I just rewrote it. So I need to find the molar mass because that's what I need to calculate. Go from moles to grams. So the formula is C13H18O2. So 13 times, using the periodic table, is 12.01. we got 13 times 12.01, 156, then 18 times 1.01, and then 2 times oxygen is 16. So all of these numbers here are from the periodic table. That's what, 32. Now we got to add them all together, and I'm going to write it over here on the side. So add them all together. And I get 206.31. And it's grams per every 1 mole. Okay, so that wasn't even the problem. That was just an extra step. So now I'm going to go back to what I was doing, and I'm taking, over here, I'm taking the moles that I calculated from the previous step. And, whoops, I didn't change I am going to multiply by the molar mass because it's 206.31 grams in 1 mole. And I want the mole to be in the denominator, so this one cancels with that one. So I'm taking the 206, the 0.1234500001296, and I'm multiplying it by 206.31. And I get still a small number, 0.1030, and then 267,378 grams. That's not very many grams. Now, significant figures, you're going to have to go back up to what we were given, and we were given 2 significant figures in the coefficient. So all we want is the 2 and the 6, but we're going to drop the 7. So then that 0.0002, it's going to be a 7, because when we drop a number greater than 5, it rounds up the digits. Now, in the current homework, they want you to write this in scientific notation. So we'll move the decimal 1, 2, 3, 4 places to the right, which is then a negative exponent. So then it's 2.7 times 10 to the negative 4 grams. And again, in the current homework, the 2.7 is in a box, and then the negative 4 is in a box. So if you get a problem that has grams, and then the other part is something small like molecules, atoms, or ions, you have to actually use both of the new tools we learned about in this chapter, both Avogadro's number and the molar mass. So it takes 2 steps to solve problems like this.